Hello guys, so we are going to continue the discussion with respect to Python, and we are going to continue the object-oriented programming series, and in this video we are going to discuss about polymorphism. Now polymorphism is a core concept in object-oriented programming that allows object of different class to be treated as objects of a common superclass. I know there will be a lot of confusion when you read this sentence, but just go ahead and read the next line, and if you are not even understanding over here, don't worry, I will show you a lot of practical example which will actually help you to understand each and everything. So it provides you a way to perform a single action in different forms. Okay. Polymorphism basically means multiple form. Okay. If you split this word, it is basically called as multiple form. Okay. And here it is written, polymorphism is typically achieved through method overriding and interfaces. So let me just go ahead and talk about this, and let me just give you a good example to make you understand. Okay. But it is my duty to probably write this kind of definition so that you also know the definition with respect to this. Okay. Now, what does method overriding allows a child class? So here I'm just going to give you this comment, see, or let me make this or remove this completely, and let me make add a markdown over here. So here you can see, let me just go ahead and execute this. Method overriding allows a child class to provide a specific implementation of a method that is already defined in the parent class. Okay. That basically means, let's say if I'm defining a parent class, okay, over there I have defined a method, right? Let's say the method will be like, if I probably create a dog class, the method is speak. Okay. So one dog makes a sound, wow, woof, woof. Then let's say that I'm inheriting that particular dog with some child class. Now that particular dog makes a louder sound, hoof, 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 hoof. So there what we are doing, we are overriding the functionality of that particular method, right? So method overriding is nothing but it allows a child class to provide a specific implementation of a method that is already defined in its parent class. So let me just go ahead and take one specific example, and here you will be able to understand. So first of all, I will go ahead and create my base class. Okay. Now this base class will be my animal class. Okay. So let's say that this is my animal class, and I'm just going to create a function that is called as speak. And here I have not written any constructor because I'm not defining any attributes. Okay. So let's say that I've used speak and with the self parameter, and it is just going to return something like the sound of the animal. Okay. Something like this. Now this becomes my base class. Now let me just go ahead and derive my derived class. Okay. Or write down my derived class 1. Now in this derived class, let's say I will go ahead and derive, I'll create a child class which is called as dog, and it is basically inheriting from animal. Okay. And then we go ahead and define the definition speak, and here we go ahead and define self, right? Now see, the method is same over here, right? If we are inheriting this particular class, you'll be able to see that, okay, fine, this is the method that I have right over here. And I can also go ahead and return my own definition. So let's say the dog makes a sound like hoof. Okay. So this is the sound that the dog makes. So what I have actually done, the same method is there, but different implementation. So here method overriding allows a child class to provide a specific implementation of a method that is already defined in the parent class. So this method is already present over there, but the child class has provided its own specific definition or implementation, right? Now let me just go ahead and create another derived class. Okay, derived class, and this time I will go ahead and create a class that is called as cat, and let this get inherited with animal. Okay, animal. Now here I can again go ahead and override the functionality of this method, and here I can say, hey, it returns meow. Okay, it returns meow. Now let's go ahead and define our or create our object. So here what I'm actually going to do, I will just go ahead and write dog is equal to dog. Okay. Now if I go ahead and print dog dot speak, now which method it is going to just call? It is just going to make sure that it calls this specific method, right? And similarly, let's say that I go ahead and create my cat. Okay. And let's say that here I will just go ahead and print cat dot speak. Okay. Now if I go ahead and execute this, here you'll be able to see that, hey, I am getting, when I go ahead and execute dog.speak, I'm actually getting hoof. When I'm executing cat.speak, I'm getting meow. And this is what method overriding is all about. The same method is getting overridden in the derived class with its own implementation, right? And I can also do one thing. Okay, after doing all these things, I can also create one additional function. So function that demonstrates polymorphism. Here what I will do, I'll go ahead and create a function, and this is a public function, not inside a class. Okay, not inside any class. So let's say that I'm going to create animal speak, and here we will provide an attribute of the class or an object of a class. Okay, and then we can just go ahead and write print animal dot speak method. Okay, now this animal that I'm actually providing, it's an object of this specific classes. Now after defining this method, I can just go ahead and write print. Okay, and I can go ahead and say dog dot speak, or let me just go ahead and sorry, it should be animal underscore speak, and here I will just be providing dog. So once I probably define this and execute it, here you can see that I'm getting hoof, right? Because as soon as I call this function, here we are giving the object of this particular class, and inside the same dot speak method is basically getting called, right? So this way also you can probably show polymorphism. But here what we have done, we have done method overriding. We are just overridden all the functions over here from the base class till the child class. Okay, so this was one example over here. Now let me just show you another way where I will be showing you polymorphism with functions and methods. Okay, now polymorphism can be also implemented using function and methods to process objects of different types in the same way, right? So here let me just go ahead and show you one base class. Let me just go ahead and create one base class. Here the class name will be shape. Let's say that I'm going to define shape. Now let me just go ahead and write definition area. So I'm going to create a function which is called as area, and here I'm going to give my self keyword. Okay, self keyword. Now let's go ahead and return the area of the figure. Okay, I'm just going to probably give a print message, and this is basically present in the base class. Okay, now what I will do, I will go ahead and create my derived class. Now see this. Okay, again here I'll also be implementing function overriding. Okay, so this will be my derived class 1. Okay, let's say that I'm going to probably create a rectangle, and rectangle will inherit shape. Okay, and if for rectangle, definitely what we require in order to calculate the area, it is nothing but width and height. So I'm just going to create my init method, and here I'm going to give self comma width comma height. This is what I'm going to pass in the runtime. I will go inside this. Now let me just go ahead and create my parameters or attributes. That is nothing but cell.width, cell.height, and then we'll go to the next sentence. Oh, sorry. This should be assigned to width. Okay. Then we will go ahead with cell.height, which will be my another attribute, and this I will assign it to my height. Okay. Now I will go ahead and call this area function, right? Now here what I'm doing, I'm overriding this area method because the functionality will be a little bit different over here, right? How to calculate an area of a rectangle? It is nothing but it will just return self.width multiplied by cell.height, right? This is what we are specifically doing. Now let me just go ahead and call the derived class 2. Okay. So here we have completely redefined, or we have overridden the entire function, right? So it's like all the functions are basically having multiple forms, as we keep on making sure that once our derived class inherits the parent class, we are basically redefining this entire function, or we are overriding the functionality. Okay. Now let me just go ahead and create another derived class, and this time I'm going to create it as circle. Okay. This will again inherit shape. Okay. Shape. So let me just go ahead and inherit shape. And now this time, I'll be using an init function, and this will be a constructor. And here what I require in order to calculate the in order to calculate the area of a circle, I just require radius, right? So here I'm basically going to write self comma radius. Okay. Now let me just go ahead and write self dot radius is equal to radius, right? So here you will be able to see that I am able to just get this particular parameter. I am able to create it. Now here also the area definition will be, the function will be different, right? So how do I calculate the area over here? I will just say return, right? It is nothing but pi r square, right? Pi is nothing but 3.14 multiplied by radius into, self dot radius multiplied by self dot radius, pi r square, right? Done. And this will basically give me the area. Now what I will do along with this, I will just go ahead and write a function that demonstrates polymorphism. And here is what I will be writing. So here let me just go ahead and write print underscore area. And here I am actually going to give the shape, which will be an object, okay, of a specific class. And we'll just go ahead and print with my f string, the area is nothing but shape dot area, right? Shape dot area, which will be my function. Okay. Now this is what we are going to just print it, right? Now let me just go ahead and create the objects. So first of all, what I'm actually going to do, I'm going to create a rectangle object. Go ahead and use rectangle, right? Basically use 4,5. In case of circle, I just need to provide my radius. So let me just go ahead and define circle with radius. Radius is, let's say, 3. Now, if I want to go ahead and just call the area function, I will just go ahead and write print underscore area. And I will give the object that is rectangle. Okay, rectangle. And similarly, I will go ahead and call print underscore area, where I will be giving circle, right? And this is how we execute it. And here you can see the area. Okay, the area is 20 and 28.25. So this is the area with respect to, the area of the rectangle, which we basically write length into breadth. So nothing but 4 into 5. And if I go ahead and calculate pi r square, so I'm actually going to get 28.25, right? So this is one amazing example. And here you can see that we have used functions. We have defined another function that demonstrates polymorphism over here. And this is one of the amazing example with respect to this. Okay. And here also we are basically playing with the same method name, but with different definition. Okay. Now let me just introduce you to, see, I've already written over here something like this, right? Polymorphism is typically achieved through method overriding and interfaces. Now let's talk about this interfaces. What is interfaces? In other programming languages, we basically say interfaces. In Python, we say it as abstract base class. Now what exactly it is, let's discuss about it. So polymorphism with abstract base classes. Okay. Now abstract base class, if I really want to define it, okay, it's very simple. Let's go ahead and see the definition. I'll paste it over here and let me just go ahead and write this. Okay. Important topic altogether. Okay. Abstract base class are used to define common methods for a group of related objects. They can enforce that derived class implement a particular method, promoting consistency across the different implementation. Okay. So abstract base class, that is the reason we say it as ABC. Okay. Let's do one thing. Okay. Let's show you an example over here. I will be defining two important things. First, I will write from ABC. Okay. Now what is this ABC? We are basically using abstract base class. We are going to import ABC. Okay. Along with that, we will be importing abstract method. Okay. This abstract method is a kind of decorator. Okay. I'll be talking about what exactly is decorator as we go ahead, right? But just consider right now, this is what abstract class is all about. You know, it is just like, it is just used to define a common methods. Okay. So I will just go ahead and define an abstract class. How do I define an abstract class? This is what I'm going to show you. Abstract class. Okay. Now, abstract class here, I'll say, hey, let's create a class called as vehicle. Okay. And this I'm going to inherit to the abstract class, which will be like an empty class itself, right? So this abstract class, afterwards I define it, I will be defining an abstract method also. See, in order to just give you a simple definition of abstract class, it is like a complete empty class, you know. There, if you are defining also method, it will be initially empty. Okay, so that is the reason why we have written that abstract based classes are used to define common methods for a group of related objects. Here, no definition will be there much. Okay, so with respect to this, now I have created this particular class. I'm not putting any information, but let me just go ahead and create an abstract method. Okay, abstract method is just like an empty method, but it is kind of common class that is probably going to happen in each and every class, because we are going to inherit this kind of abstract class onto this, right? So here what I'm going to write, I'll just go ahead and write define start engine. So this will basically be my function, and here I'm going to use my self keyword, and since it is abstract, it needs to be empty, so I'm going to just write pass. Okay, so this is how I have actually created my abstract class. Along with that, I am also created my abstract method called as start engine. Now what I will do for my derived class 1, I will inherit this. Okay, so let me just take class car, and here I'm just going to use vehicle. Okay, now you know that I have defined my abstract method, which is completely empty. Now I can, since I'm inheriting vehicle, I'll also be inheriting this particular method, and I can define my own function. So that is the reason we'll go ahead and write definition start underscore engine. Okay, start underscore engine self, and we are just going to return over here car engine started. Okay, some information, car engine started. Okay, and here you can define your own init method also inside this particular class also, right? Define any number of parameters that you want. Okay, now similarly, if I go ahead and create my derived class 2, you will be seeing, hey, let's go ahead and create this particular class called as motorcycle. Okay, and here I'm actually going to give my vehicle. Okay, vehicle class, and let's go ahead and inherit it. And if I go ahead and write definition start underscore engine, here I'm just going to return motorcycle engine started. So here you can see this function is having a different definition inside motorcycle class, and it has a different definition inside the child class. Okay, then let me just go ahead and create the object of the car. So create objects of car and motorcycle. Now see, I will just go ahead and create it. Okay, and we can do the same implementation like this also, right? So I've inherited over here. Let me just go ahead and define one function that will demonstrate my entire polymorphism. And now I can just go ahead and start this vehicle, and just let me define my car. And if I go ahead and execute it, you can see that automatically it is being able to call this called as start engine, and here we are able to display it. So here I have actually shown you polymorphism with the help of method overriding. Along with that, we have also seen with the help of abstract class. So this too you definitely need to know. And again, ending this session, I will try to provide some conclusion, which is a good habit. Okay, so here with respect to the conclusion, you should know why polymorphism is important. It is a powerful feature of OOP that allows the flexibility and integration in code design. It enables a single function to handle objects of different class, each with its own implementation of a method. By understanding and applying polymorphism, you can create extensible and maintainable object-oriented programs. Okay, but here we are just seeing that what all features it has with respect to polymorphism, right? So yes, this was it for my side. I hope you like this particular video. I'll see you all in the next video. Thank you. Take care.